The ATHL9010 UAV LiDAR Hyperspectral Imager consists of two parts. The first part is the UAV flight platform. The second part is the LiDAR Hyperspectral section. First, the UAV flight platform. Packaging: aluminum case, fuselage, 232,000 mAh lithium batteries, 6 arms, 6 carbon fiber propellers, remote controller with built-in screen. Next, the hyperspectral section includes a 3-axis stabilized heavy-duty gimbal. The hyperspectral imaging method is external push-broom. The wavelength range covers 4001700 nm, an onboard LiDAR, and an onboard computer that functions as the hyperspectral acquisition software and storage path device. Below the onboard computer is the IMU section. Here is a data cable that plugs into the onboard computer interface. This cable is for the LiDAR. These two are the hyperspectral camera connection cables. This is a portable touchscreen display. This part is connected to the onboard computer. Next, I will demonstrate how to assemble the hyperspectral unit onto the UAV flight platform. First, we can assemble the hyperspectral part. This is the power cable for the gimbal, which is powered by the UAV lithium battery at 12 volts. Before assembly, these two buttons need to face outward to push it in. There is a slot inside. Push it in, then rotate it to the left to lock it. To remove it, press the small button on the outside, rotate it, and pull it out. This hyperspectral and gimbal assembly will be installed onto the UAV. Now, I will demonstrate how to install it. The LiDAR has two M12 connectors at the rear. One is a 4-pin M12 power connector, and one is an 8-pin M12 gigabit Ethernet connector. This step can be completed with 2 people assisting. It is best to start with the 4 copper posts from the diagonals, aligning them with the hexagon socket hand screws. Do not tighten them fully at first. After the 4 hexagon socket hand screws are basically in place, then tighten them. The payload has 4 cables. One is a GPS cable, which plugs into the onboard computer. This is the LiDAR cable. This is the 4-pin M12 power connector. Align and screw it in. Align and screw in the 8-pin M12 gigabit Ethernet connector. The other two are the hyperspectral camera cables, each connected to the onboard computer. Next, assemble the UAV. When installing the arms, ensure that the numbers 1-6 on the arms correspond to the numbers 1-6 on the fuselage. The aluminum parts on the arms and the fuselage have designed mounting angle positioning planes. When installing, the motor should face upward. Based on the arm number and the markings on the propeller mounting screws, select the correct clockwise and counterclockwise propellers for the corresponding arms. That is, while the motor remains stationary, choose the propeller based on the blade direction marking. Due to the self-tightening effect when the propellers spin at high speed, it will require significant effort each time you remove the propellers. You must use the propeller removal tool to take off the propellers. Remember not to use excessive force. First, insert the battery into the battery mounting slot. Then secure it with a strap. When placing it into the battery slot, tilt it slightly. Do not use excessive force during installation. Take out the remote controller. Press and hold the center power button. Then swipe up and tap the ground station control software to enter the flight interface. Wait for the progress bar to finish loading. This indicates that the remote controller has established a connection with the flight control system. After the UAV is powered on, it will emit a beeping sound, which indicates it is in a locked state. The GPS includes a safety lock. Press and hold it for 3 seconds to unlock. Next, we can use our phone to enable a hotspot. The remote controller has an internal Android system. Swipe down, turn on Wi-Fi, and connect to the phone's hotspot. Next is the UAV flight check. Select Flight Interface Control Bar Aircraft Control Check in the ground station. The ground station will pop up a checklist window. Next, click on Other and select RTK. After connecting to Wi-Fi, we can select a nearby location. Log into the RTK account. It will display cores connected here. Now, let's switch to the flight screen. We need to plan a flight route first. I can set an area-shaped flight band. Set the corresponding parameters: flight altitude, flight speed, lateral angle, side overlap rate, etc. The sensor parameters are set to factory defaults. Edit 4 points to adjust the size and orientation of the area. After setting the parameters, click Save Folder. If the editing is complete, click this file, then save, enter a name, and click OK. Now that the preliminary UAV inspection and flight route planning are complete, we will now power on the onboard computer. Here is the power button. Press it gently. Here is the display screen. This is a dual-ended Type-C cable. Plug it in, and after waiting a few seconds, it will boot into a Windows system. After powering on the computer, right-click on this PC and select Device Manager. Check if these windows are connected properly. Basilar camera, Select the acquisition software and double-click to open it. The software interface is divided into 3 sections. The first section is the preview function, the second is the acquisition function, the third is the parameter settings. The preview function does not store data. It only serves as a preview. The acquisition function saves data. For the third section, there are 2 cameras and LiDAR parameter settings. The parameter settings for the 2 cameras include flight altitude, flight speed, frame rate, and exposure time. Flight altitude and speed need to match the parameters set in the UAV remote controller. This is the frame rate, which is the acquisition frame rate of our camera. Exposure time needs to be determined based on the weather conditions. It can change. These parameters are subject to change. This is the 4-in-1 setting. This is the storage location. Choose where to save it. After changing all parameters, click Save. For the second camera 900nm/1700nm, the settings are similar. Assuming the altitude is 100 meters and the flight speed is 4 meters per second, the frame rate is 33. This can be adjusted if the altitude and flight speed are modified. You need to click this gain calculator. It has a built-in algorithm that calculates in real time. You need to click it. Then, for exposure time, the maximum exposure time is 35, the minimum is 5. After modifications, click Save. Third is the LiDAR, with settings for its power, frame rate, battery level, and acquisition duration. If these parameters are modified, also click Save. For the LiDAR, the 2 cameras can be modified based on actual acquisition conditions. In the lower left corner of the interface, regarding the LiDAR, we have options for acquisition or no acquisition. If acquisition is not needed at times, you can click Disable to turn off this function. Regarding the 2 cameras which cover 400-1000 nm and 900-1700 nm, you can either enable both cameras simultaneously, or select a single camera, or choose not to capture with either camera and only capture with the LiDAR. First, click Start to open the Hyperspectral camera. Check Acquire Dark Current and then Acquire Dark Current. There is a Subtract Dark Current function later. There are 2 lens caps below the Hyperspectral camera. Before acquisition, we need to acquire dark current. Enable this button. Acquire dark current for about 5 to 10 seconds. After about 10 seconds, click Stop. Before takeoff, remove the lens caps. This is a 50-50 cm diffuse reflectance panel. How do we use it? First, when planning the flight route, we need the UAV hyperspectral system to capture it for radiometric calibration and reflectance calculation. When using it, do not touch the panel surface with your hands. On the back, it indicates the wavelength range, size, and reflectance. Place this white panel within the UAV's flight path. Since we are currently close to the UAV, before takeoff, place the white panel in an area with no obstructions around. Before UAV takeoff, click Acquire Spectral Data. After clicking, unplug the display screen. For the planned route, upload it and then download it. Switch the screen. Swipe the takeoff button. The UAV takes off, waits for the route mission to complete, and then returns automatically. After landing, lock the GPS safety lock. Use the portable display to connect to the onboard computer and click Stop Spectral Acquisition. A prompt to subtract dark current will appear. Wait for the dark current subtraction to complete. The raw data can be copied to a desktop computer for data processing. When disassembling the UAV, unplug the battery power. Use the removal tool to take down the propellers and arms. This completes the entire installation and operation of the ATHL9010.